Section 1.6 number 10 seems to be giving some folks some trouble. One thing I noticed as I read through it is it talks about two gardens, and both gardens will have the same amount of fencing. That is, both gardens will have the same perimeter. The difference is that one garden is in the shape of a square and the other is in the shape of a triangle. There's one other helpful thing in here, and it says each side of the triangle is 7 meters longer than the side of the square. So if we look at their labeling over here, they've already labeled the square as having a side length x. So if the square has a side length of x, then each side of the triangle has to be x plus 7. And this is how we can use the perimeter. For the square, the perimeter is x plus x plus x plus x. In other words, add up the length of all four sides, and then you get the perimeter of the square. Now it says that this is an equilateral triangle, so that means not only is the side that I labeled x plus 7 have a length of x plus 7, but all three sides have a perimeter of x plus 7. So x plus 7 for the first side, x plus 7 for the second side, and x plus 7 for the third side. This gives us the perimeter of the triangle. And so if I combine like terms, I get that 4x is equal to 3x plus 21. I just added the x's and added the constants. And with just one more step of algebra, I can find that x equals 21, so a side of the square is 21 meters, and the side of the triangle is 7 more, is 28 meters. They're definitely 7 apart because I added 7 to get from 21 to 28, and it's easy to do the reasonableness check just by actually checking it. If you add up 4 21s, you get 84, and if you add up 3 28s, you get 84. So we have this right. And just a quick peek back at the original problem. It says find the dimensions of the garden. Didn't say which garden, so I guess it was good that we actually came up with the dimensions of both gardens.